Let's solve this calculus problem step by step. We'll verify that for the given function, a certain expression equals 2p. Let's start with our given equation. We have y equals px plus q divided by x, where p and q are constants. Now, let's find the first derivative. When we differentiate y with respect to x, we get dy dx equals p minus q over x squared. This is because the derivative of px is simply p, and the derivative of q over x is negative q over x squared. Next, let's find the second derivative. The second derivative d squared. Y over dx squared equals 2q over x cubed. This comes from differentiating negative q over x squared with respect to x. Now, we need to evaluate the left side of our equation. The left side is x times the second derivative plus 2 times the first derivative. Let's substitute our derivatives. We get x times 2q over x cubed plus 2 times the quantity p minus q over x squared. Now, let's simplify. First, x times 2q over x cubed simplifies to 2q over x squared. Then we distribute the 2, getting 2p minus 2q over x squared. Finally, the 2q over x squared terms cancel out, leaving us with just 2p. And this matches our right side, verifying that the equation holds true. To summarize, we took a function, found its first and second derivatives, and verified that when we substitute these into the expression x times the second derivative plus 2 times the first derivative, it equals 2p. This is a beautiful example of how derivatives can be used to verify mathematical relationships.